Hello, this is a pre-recorded version of the talk I'll be presenting at BrisBimX2016 on real-time rendering and VR for BIM. If you want to learn more from me, check out my podcast at thearchitectshow.com. My name's Joe Banks. So real-time rendering, what is it? Well, basically it's similar to traditional rendering in that you're sort of simulating lighting and surfaces to produce ideally a photorealistic image, but you're doing that in real time, so you need to do it 60 times a second rather than taking minutes or hours or days to complete that task. And we're able to do that by leveraging the power of the gaming industry and the advances in GPU technology. So what does that mean? Well, in the last year there's been a pretty remarkable increase in the GPU performance that's available to us. So on the right hand side there, the Titan X, that is the most powerful card that you can buy in 2015, and it costs about $3,000, and that is pretty much what you needed to be able to do VR and high resolution real-time rendering. In 2016 you can now buy a GTX 1080 at the top in the middle. Now it is about $1,000, so it's a third the cost. It uses about half the power and it performs about 3 times as well. That's very impressive, and it really makes this field of VR and real-time a reality that we can achieve, relatively economically nowadays. So that's not the end of the good news. We're currently at this Pascal level on the graph on the left there, the second last dot. So the next level up, or the next development, is going to be the Volta series, and that again looks to be a pretty exponential increase in a fairly short period of time to the processing power that we'll have available. So there's definitely good things to come and more hardware to enable what we're trying to do. So what I'm going to show you here is a tool called Panoramic Pro 2. Now it's basically a web building tool that allows you to put together spherical images in a kind of a tour that you can view in a Google Cardboard or any of the other kind of viewers. So you can see here I jump in, I'm just moving my mouse around to move the image. So this is a photo taken with a 360 camera, and all we've done is build a little graphical user interface here where I've got some controls, and I've got a map on the left where I can click to jump to another spherical image. Now it doesn't just have to be images taken with a camera. This here is a 3D spherical image rendered out of Studio Max. So this is leveraging the existing render tools and render path that you have in your office to produce this kind of stuff, but now you've got a spherical image rather than a flat image. So we can look around, we can plug this into a Google Cardboard and get a fairly immersive experience. And using Panoramic Pro we can link these up using like these little glyphs or little menus, etc., to enable us to jump between different renders in much the same way that Google Street View allows you to sort of jump around between those spheres. This is a really good tool if you want to get to VR without having to sort of learn something new or do something that or invent a new workflow within your office. The downside of it is that it's somewhat fixed. So I can't move the position that I'm standing in, I can't change the lighting, I can't change the materials, I can't animate things, I can't have water or particle effects, or I can't simulate anything other than what it is in this sort of one fixed moment in time and space. So the main reason I'm showing you this as well is that some of the tools that we'll be going through later have the ability to output a spherical image, and I think that this tool is a really good one to actually put those together in a professional presentation. So the main players in the market right now for real time are Fuzor, Enscape, Revizto, Clever, Lumion, Live, Autodesk Live, LumenRT, Twinmotion, and these gaming engines at the bottom. Now The prices for all these are a little all over the shop. The range is quite broad, and it kind of depends what you want. You do kind of get what you pay for to some extent. So some of the cheaper tools are either going to be limited in their capability, or they're going to be limited in the amount of sort of user friendliness. So a good example is going to be the gaming engines at the bottom. They tend to be very cheap. They're either free or quite cheap. However, there's not a lot of sort of out-of-the-box one-click solution. You tend to have to do a fair amount of work to get a real professional and polished product that you'd show a client. Where some of the other products like Fuzor, for example, is sort of middle of the range for pricing, but provides a sort of one-click out-of-the-box solution and a huge amount of other tools. So my point is, I wouldn't choose which engine to invest your time in based purely on the purchase price. You really need to look at the life cost of that. So if you're going to be spending a huge amount of time developing processes, there's a lot of man hours involved, particularly with the gaming engines. You do need to keep that cost in mind when you're trying to sort of make the case for these. So we'll just go through all the things that are available at the moment and why I've broken them down into some groups. So the top group here, I've got Fuzor and Enscape. I've sort of sectioned those off because they're the only ones that actually have a live link to their authoring program. So Enscape has a live link to Revit and Revit only. Fuzor has a live bidirectional link, and it's the only program with a bidirectional link to Revit, ArchiCAD, Rhino, and SolidWorks. The SolidWorks stuff is in beta at the moment though. So what that means is I can make a change in ArchiCAD and see that reflected in real time in Fuzor straight away. I can also move something in Fuzor, change its material, or one of the other things that I can edit, and see that reflected back in my authoring program in real time. That does vary slightly by what actual data exists in the original program. So the 4D data, for example, won't necessarily push back into Rhino. The ones at the bottom, so Clever, Revizto, and Autodesk Live, these work much more on the idea of exporting out from your authoring program and then into sort of a proprietary program. So I won't talk a lot about Clever, but there is a new version with a lot of new features and basically a whole new tool coming out in sort of March, April, so just look into that when it comes out. But Revizto works very much on a export out to either a local or a cloud location, and Autodesk Live works on a sort of an upload process in the cloud and then download a proprietary file at the end of it. The next group here, which is Lumion, Twinmotion, and LumenRT, they are very much based on an export to a proprietary file format and then import process. So you export it out and then you bring it into these engines, and in the engine you want to either swap out all the materials, you want to add entourage like people and animals and cars and those kind of things, terrain, planting and landscaping, all of those things. So the workflows for these tend to be set up very much around doing a lot of work in these engines, so rather than in the original authoring program. And the final group is going to be the gaming engines. So we've got Unity, we've got Unreal, CryEngine, and Autodesk Stingray. Now, Unity and Unreal are really the two that are getting used quite heavily for architectural visualization. Have seen some cracking stuff done out of CryEngine. And Autodesk Stingray, which is a bit of a new player to the market in some respects, is starting to make some headway. For me, I'd probably give it a year or so before I really put any more time and effort into it. I did dig into it fairly deeply, wasn't particularly impressed, but there are some impressive things coming, particularly in relation to physics-based materials in the engine, so that could be a bit of a game changer for that engine. Gaming engines. The only limit here is your wallet, your skill, or your time. and how much of this you want to embed into each of these engines to get the desired result. There's not a lot of limitations in these things. If you're willing to put the effort in, you can get a pretty no compromises solution to whatever your goal is. So yeah, we'll talk a bit more about that later. So what's the point of all this? Well, this is realistic mode in Revit. This is about the only place where we can just go to a location and see what it's going to look like without having to wait for post-processing time. And it looks rubbish. It's not really practical to present to a client, and it doesn't really translate the information that we need it to. This is ray trace mode. It's slightly better, it's not great, and that takes 5 minutes. This is Autodesk Ray Tracer. That's not great either, and that took 8 minutes. What I really want to be able to do is see these things instantly. So this is Mental Ray. It took 20 hours to do this render, and it's not a particularly pretty render. It's still quite grainy. I haven't used this rendering engine in years because it's kind of a waste of time. This is Revizto. So this is effectively giving me a similar image. Some of it's better quality, some of it's lower quality, but it's quite good. And it's doing this 60 times a second. So there's really no render time at all. This is Enscape, which will pretty much do this in no time at all. There is a slight pause where it sort of blurs as you move around, and this is if you let it go for a full minute, but it basically looks like this all the time on good hardware. This was a full minute on my sort of 4-year-old laptop at the maximum settings. So this is Fuzor. This is on the same laptop, and it's doing that at 60 frames a second all day, every day. It also handles really large models quite effectively. So you'll see the materials look pretty good. It handles the bump maps, and I don't have to wait. I can move to any point in space and see this in essentially a rendered view. So to talk about some quick features of these pieces of software, Enscape, the big pros for this is it's low cost and ease of use. So it's really easy to use. You can pretty much become an expert in about 15-20 minutes. You're getting better rendering than Revit in less than a minute, and you can get to virtual reality in 2 clicks. So you're sort of launching Enscape and then clicking VR mode, and you're in. One of the deliverables I like for these, and most of the stuff I'm about to show you, is a standalone EXE or a viewer that you can send to a client, and then they can explore the entire model in their own time as well. So the cons to this really is just it's a limited feature set, so you can only do so much in here. Mostly it's just visualization. There's no post-production options. That's partially a pro as well, in that anything you do also needs to be in Revit, and it is Revit only. Here's a short video basically showing you the process. You go to the plugin, you launch Enscape, and it will launch into the viewer. And you can see me moving around here in real time. So I don't have to wait for any of this to render. It's essentially rendered within a second or so of me stopping moving. So you see when I make quite big dramatic moves, it'll take a little bit longer. But ultimately, this is a render good enough to show to clients, to talk to them about design iteratively as you're moving through, and make informed design decisions and communicate your design really effectively. There's a bunch of options in there to sort of adjust that image. So yeah, I encourage you to go and grab a trial and see if you like it. Revizto. So the key features of this are it's quite easy to use, the cost is quite low, it's got quite a heavy focus on collaboration and issue tracking and markups. So it's a really clever use of real time in that you're trying to focus what you're doing on actually, I suppose, simulating a real world inspection. So you're walking through the model trying to find issues, then you're or something that needs resolution, you're marking that up and sending it off to the group. And you can do this with lots of people, track those issues until they're resolved. The real cons here are not a lot. It's It doesn't have the live link, but you can schedule an upload, so it's not two-way, and there's a relatively limited feature set compared to, say, Fuzor, for example. The deliverables are pretty good. The integration's quite good. It's Revit, Navisworks, AutoCAD, Civil 3D, SketchUp, and ArchiCAD can all essentially export into Revizto, and it supports FBX, IFC, and even PDFs if you want to put other documentation in there. So integration is quite high, and the workflow is pretty straightforward. You're clicking on the name, you're clicking on the project, so nominated project, and then clicking on the that section in the middle is the Revit plugin. Clicking export to Revizto, picking the options. There's not a huge amount to pick from, which is good, and just clicking export and it'll pump that out for you. And you can click on that export scheduler so that you can have that happen every night automatically if you want to. Once it's exported in, you can walk around it in on your desktop or with the VR headset on, and when you find an issue like this, you can click on an object, create an issue. I don't think you can create issues with the VR headset on, but you can certainly explore the model. Once you've created an issue, you can assign it to someone and track its progress until it's resolved. And here's a short video just showing the, I suppose, the graphic quality of it. It's certainly good enough to find issues with the model, to communicate design, to work with external consultants, even with clients, depending on who the client is. I suppose to help you build better buildings. I encourage you to go and trial this. I think it's probably worth your time to dig into a bit and see if it's the right solution for your company. But yeah, ultimately it does quite a good job of what it does. Fuzor. Now, I would love to talk about this for quite a long time, and I'm probably going to chuck up a bunch of other videos on this software because there's a heap to talk about. But this is just sort of a quick pass at some key features that are interesting. So some of the standout ones here are 4D animation and construction sequencing are quite good. There's lots of simulation and analysis tools for like weather and lighting and clearances and those sort of things. There's a clash detection and Navisworks integration are quite good. One of the ones I've been using a fair bit recently is the being able to just load in a point cloud or a photogrammetry textured mesh and then walk around that object. It's a really good way to get a feel for the site and what's going on without having to sort of be there, and you can do that in VR as well. One of the key things that these guys have worked on really hard is to integrate VR into every part of the software. So this is a 4D simulation. It's quite a detailed one. There's a few hundred steps to it, and what you'll find is that pretty much any part of this can be edited from the desktop or from within the VR environment. So you don't have to pull the headset on and off every 5 minutes to make a change. And the live link back to Revit, which I think is probably its killer feature, enables any data that you enter in here in Fuzor to be synced back to Revit and vice versa. So a good example here is you can put the VR headset on, go and stand inside this building, and using the Vive controllers you can play the sequence back and forth and watch the elements around you sort of be built and make sure you're happy with that sequence. And I don't really know of any other program that'll sort of let you dig inside in that way. You're generally on the outside looking in when you're trying to figure these things out. But not only can you view it from the inside, but you can use the Vive controller to actually select those objects and change its time of construction within the sequence while still remaining in VR. So it's pretty standout and unique in that you can essentially do everything in VR without having to jump out and use the desktop. Another example here is a new feature is this heat map render mode. So the color gradient that you're looking at on all the surfaces represent the lumen level on those surfaces, and there is there are some numbers to go with that gradient chart on the right, but this is a snapshot from a beta version. But basically, if you've got some specific lumen levels you need to hit, you can come in here, whether it be on the desktop or within the VR environment, select the lights and adjust those levels until you're happy with them or meet the requirements you need, and move on. A new sort of feature that I think is a really unique feature and really clever is that it allows this sort of independent use of the client who is in VR and the operator. So no other program sort of lets you do this at the moment, but essentially the person walking around in VR can independently explore the model, talk to the operator about something they want changed. The operator still has the full use of his mouse and keyboard and his own navigation to be able to go and change those things, and that will be reflected in the VR environment that the client is looking at straight away. So it sort of allows that person to keep moving and keep doing things productively without having to wait for the operator or the operator waiting for the user, because you don't really want to have to stop and take the headset off to make a change and then put it back on. So I think that's a really exciting feature, and I've been using it a fair bit. It's quite good. So the last thing here is that we can do measurements, moves, edit, the place objects, delete objects, all of this still while we're in VR. Something that comes up regularly is people in there asking, oh, how high is this? How wide is this opening? That sort of thing. So they don't have to get you to do that. You can do all of those things with the Vive controller directly in VR, which is pretty cool. It's also compatible with Google Cardboard and Google Daydream, although I haven't been able to get my hands on a Google Daydream to try out the controller yet, but I'm quite looking forward to that. So this is Autodesk Live, and this is the basic screen you get. You go into Revit and you get Go Live, and the screen on the left will come up for uploading. Now, being in Australia, sometimes that times out, particularly with larger models, and you'll get the screen on the right, where basically the server speed is quite slow because the server's located outside of Australia. Hopefully there'll be an Australian service soon and we won't be getting these kind of issues. It's mostly just happening with larger models. It's built on top of the Stingray engine, and I keep finding at the moment that really it should probably still have a big beta or maybe even an alpha sticker on it. It's got a lot of issues, but I would say to stick with it. Because the team is working pretty hard on it, and I think it's going to be a pretty useful product within maybe 6 to 12 months. If you can see in this image, it's very overexposed. There's no ability to manually control the amount of light in the scene. It's doing that automatically, and it's kind of messing it up. There's also these big artifacts, and if you click on one of those big objects in the background, you'll get this crash straight away. So they're the objects in this particular model. So I've had this on a couple of models that are producing this. I'm not really sure why. I've reported it as a bug. Hopefully it'll be solved, but if you're getting them on yours, don't click on them, it'll crash. Don't get any of those issues in the default Revit sample file. So the lighting tends to be okay, and the no artifacts or objects. The trees are quite pretty. I think they're using speed tree trees. But yeah, if I jump inside, I've got a lot of exposure issues. I can't really show this to a client the way it is at the moment, but check back in. I'm sure it's getting better every day. One of the nice features that they added, which is, it's a little bit gimmicky, but you can sort of click on a position in space for navigate, this tap and go feature, and it will essentially find the nearest entry point, a door or a stairwell, whatever it's required, and then navigate to that point in space. One thing that they don't have, which they really need to add, is just a typical fly mode or a walk mode, so you can just navigate in a traditional video game type of way, because it can be quite clunky to get to where you need to go the way it is. So Lumion. Lumion's got quite the focus on visualization. It's effectively just for visualization, and it does a really good job, particularly with foliage and entourage. These are sort of some fairly typical shots of stuff that's done with Lumion. There's a lot of post-processing, but you'll also notice that most of the geometry we're looking at is not created in the authoring tool, it's created in Lumion. So this is kind of an example of what not to do, because most people here are just looking at the ocean and the rocks and not really at the building that you're trying to sell them. But if you do have a project that's near water, this does a really cracking job of water. So there's a short video here of some of the new features in Lumion and Lumion 7. All these new glass features look really good. The assets that they've included let you do some really high-end visual stuff, and the ability to sort of move around and take new shots anywhere you want in a real-time way is still there. This wet asphalt look that you can see there is really good. The speed ray reflections, here's the wet asphalt tool in action, and it's kind of amazing how just adding a small bit of realism into an individual shot like that can really lift the entire frame, and it's much easier to sort of believe that the whole image is real if sort of some key parts of it look particularly photoreal. Yeah, water clouds, all of that. Mobile integration's quite good. But again, I've noticed it's a bit more of a traditional rendering workflow that they're looking at, where you export out and you spend a lot of time post-processing, changing materials, changing individual lighting, and where light's coming from, that sort of stuff, if you really want to get this photorealistic result. So yeah, it doesn't actually do real-time VR, so you can't sort of walk around with the goggles on, but you can save out these sort of stereoscopic panoramas here that can be viewed on mobile or in Google Cardboard or a Galaxy Gear here. So LumenRT is a product that was recently or a while ago purchased by Bentley. It's quite good. It does a good job of, particularly good job of traffic. You'll notice these cars actually are like giving way to each other and that kind of thing. And it does the same thing with sort of other visualizations or other sort of entourage interactions. One cool thing they're doing now is you can upload your model onto the Bentley website, and they'll essentially build you this with a video and a viewer file and send it back to you, so you can sort of trial it without having to do any of the work and see how it would look on your building. I'm pretty sure they're only going to do that once, so I wouldn't expect that to be your new production workflow. But I've had a good play with the engine. It seems quite robust. It did seem to struggle a bit with really large models, although most of the engines did. And the trees are particularly nice. I tried adding a heap of entourage, people walking around and that, and it seemed to handle that quite well. But again, it's sort of similar to Lumion in that regard, in that you sort of need to export out and go through a whole post-processing workflow of swapping out materials and sort of adding things inside the LumenRT engine. The next one I'd like to talk about is Twinmotion, and this was a real standout for me that really surprised me how good it was, because I reviewed it a few years ago and didn't think that much of it, but it's quite good now, quite different. So this is sort of a quick video that I made very, very fast. I was sort of into Twinmotion and got this video out in about 20 minutes. It does require some post-processing. It's pretty quick, so it required me to basically swap out the glass for the Twinmotion glass, and the same for the most of the other materials, but it did group them all, so it was sort of a one-click process per material. Yeah, it does have the ability to display real-time VR. You do need to go to this BIM motion tab, which is a little bit hard to find, and click on enable stereoscopy, and then it'll essentially give you a VR mode that you can explore the model, and this will also export panoramas if you want to do it, if you want to work with that as well. So one of the other tools I wanted to highlight that's particularly good in this engine is just how sort of intuitive and powerful the graphical user interface is for things like setting up the scene and populating like these groups of people walking through. I did actually make a model where I sort of simulated like a huge crowd, like 100,000 people kind of, you know, zombie horde level of people, and it seemed to handle that really well. I have noticed that some of the others like Lumion don't seem to handle really large numbers of that entourage as well as Twinmotion is doing it. But yeah, full credit to the developers. This user interface is really intuitive, it's really easy. I found I wasn't sort of struggling to understand what to do and got my way around it quite quickly. So gaming engines, given what we've seen in the other engines, why would we want to make the next leap up to gaming engines? Well, because there's sort of freedom to do things that aren't in those proprietary engines. So if we have a look here, we've got a sample file that we built at BVN. It's of a small unit. And you can see this basically looks like the panorama that we were looking before, but the key difference is that I can sort of move to any point in space and go and have a look around. So if I just sort of jump in here to the kitchen, you can see I can look down at these beautifully textured chairs. I can essentially look at what would be a fully rendered shot of a kitchen, good enough to present to a client, and I can do all of this in real time. I don't have to you know, render from a specific point in space. It's pretty impressive stuff. The workflow to get from your authoring tool into one of these gaming engines is comparatively quite long. So with most of these other tools, it's sort of one click or an export. This is sort of a multi-step process, and to get it to look this good, you know, it can take, you know, hours, it could take days, depends what your workflow is and what level of quality it is that you're trying to aim for. So this video is from an Unreal enthusiast. We might jump forward a bit, but you can see they're basically taking advantage of some of the cinematic keyframe to produce what would otherwise be a fairly complicated sort of render frame by frame. You really just need to set the path and you can save the video out in real time. But the other thing we really want to look at here is now we can walk around this space in real time. We can start to interact with objects, so we can build in pre-made selectors like the ones you're seeing here. They can swap between both material configurations or physical configurations or layouts of objects, and we can interact with other objects in the space like the lights or the tap or other things that we would like some action or animation for, opening, closing blinds, that sort of thing. This has a lot of applications in sales to end clients, and there's also a lot of, I suppose, capacity there for the information that's gathered in this environment to then feed back into the documentation package. So if a client goes through and picks a particular combination of colors, that can then be saved out into a form so that we know what to order on site, and there's no confusion about what they're getting. So this is a video kindly lent to us from In Any Real Time, Jeremy Harkins, who's spoken here before at BrisBim, and this is of the Barangaroo project, a Lend-Lease project in Sydney. So it's mostly the three main towers in front of you and some buildings in front of that, and you can see them fully sequenced in 4D. And I've certainly heard in the past people say that gaming engines are not really capable of dealing with these really huge data sets. That's clearly not the case. This is a highly detailed model, and you can see the LODs change as you approach stuff. Full fit outs of levels are all included, and it uses a lot of gaming industry tricks to I suppose, load only what you need when you need it. And yeah, what they've really done, which I was particularly impressed with here, is integrate a lot of the things like design options, like these little railings, that sort of thing, the full 4D sequence, and the real-time feedback from real-time sensors. So the sensors on site that are installed in the building are being used with this engine as a facilities management tool. So as we go and look at these shutters here, we can open and close those and actually affect what's happening in the real world, and vice versa. If we go and have a look at some sensors in the mechanical model here, we can see the actual live data from the sensors on site displayed in the real-time model. And that's a really good way to sort of manage a whole building and do your facilities management from a single point. You don't have to log in and out of 20 different systems to sort of understand what's going on. It allows you some contextual information. As well as, yeah, there's all these kind of space planning and visual things that you can do as well. So just looking here at another product called AMC Bridge. This is built on top of the Unity gaming engine. So it's not actually like a Unity product, but it's built on top of that. It actually uses an older version of Unity. But it's free, and it's a one-button video game maker. It's on the Revit App Store, and essentially you get this tool in Revit, the button at the top left. You click that, you type where you want to save it, and you hit OK, and it just saves it out. Now while that's launching, essentially what it's doing is it's going through all of the steps to export it out, do sort of material conversion, load it into the Unity engine into a pre-made level with all of the controllers and the player and environment settings, etc., and then saving that back out as a .exe that you can simply load and play when you want to. So we can see here some fairly basic options here, but we can come in here and change the day and night time, and we can have that sort of auto rotate, or we can pause it. We can change the sun location, north, south, east, west. We can chuck in some particle effects. We can do rain simulation. We can do snow simulation. We can do a heavy snowstorm. And seeing as it's snowing, we should probably add a little bit of fogginess to it. We can go really foggy, but it's a bit overwhelming. And maybe some clouds in the background. If we pull that out, you'll find that we get a pretty nice sort of engine, and we got here for free in one click. And you can send this to any of your clients. They can fly around, walk around, check stuff out, see if they're happy with it. It's pretty robust and unbreakable, and yeah, it costs you nothing. So one thing about the VR with this, it does work, and it works quite well. It only works with the HTC Vive. It will detect when a Vive is plugged in, and you'll have to hit launch in VR mode when it pops up. But basically when you click on the Vive controller, you'll get that same in-game menu that I was showing just before, so you can still make all of those changes in VR. And yeah, for free, it's kind of exceptional value. And yeah, if you want to just jump into VR and check some stuff out with very little work, this is a great place to start. This is a game or a visualization built in Unity by just a hobby user. Obviously a huge amount of work has gone into this. Basically it's just using the cinematic tools of I think it's 2 versions ago of Unity, so it probably look even nicer with the latest version. But I just wanted to highlight that the visual quality you can get out of Unity is pretty staggering as well. So certainly don't feel restricted by what tools you can and can't use here. So this is the Atom Part 1 video. It's a demo from Unity, and it really highlights the high quality that you can achieve using these gaming engines. This is next gen stuff. It's available right now. You can download it and start using it. There's a video showing how they achieved a lot of the effects in this. The particle effects, the cloth effects, the orange cloth materials on his arms and legs are perfect. I can't fault them. This really looks to me to be at the same quality as a full Hollywood high-level movie, but it's rendered out in real time. There's no post-processing. There's no slow iterations or that sort of thing to get this thing out. So we won't watch the whole video, but yeah, if you get time, dig into the video of how it was made. Thank you very much for watching, and hopefully you've learnt something helpful.